input that's omitted. Now we're ready to compute the multiplication table. It's actually pretty simple. We create two row vectors, one going from 1 to n and the other from 1 to m. We transpose the first vector to be a column vector and use matrix multiplication to create the table. Now it's time to determine whether we need to compute the sum of the matrix as well. We need to do that only if the user requested a second output argument, so we check nargout. If it's 2, we call the sum function. Remember that sum computes the sums of the columns of a matrix and returns them in a vector? Well, that's not what we want. So here, we use the column argument to create a vector from all the elements of the table. That's done with a colon. And then we sum and give that to sum and it'll add them all up. If nargout is 1, then we avoid sum entirely. But there's no harm in computing summa, even if the caller doesn't request it. If we calculate it when the user doesn't request it, MATLAB will simply discard it when the function returns. So all we've done is save a few microseconds of calculation time here. But you will definitely want to use nargout to avoid long calculations, perhaps many minutes, when the user doesn't ask for them. In any case, here's our first polymorphic function. Let's see it in action. Well, here's our mult table function in the editor all ready to go. Let's pitch it a few different inputs to see how well it does. There we gave it 3 by 4 and it gives us a 3 by 4 array, and that looks like a multiplication table. Let's ask it for a couple of outputs. There's the table and there's the sum. And that's the correct sum. Okay, this time we just asked for one output, but we only gave it one input argument. And you'll remember that that defaults to 5 by 5 instead of just 5. So far, so good. It's hitting them out of the park. Let's see how it handles a curveball.